Hello viewers, welcome back to class. Now I'm super excited to welcome you guys to Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so, and do ensure that you turn on the post notification bell for more exciting videos. Like this video, share this video, and make your necessary advantage. Guys, for your own advantage, do not skip any part of this video. And ensure that anytime you are set to watch and to learn new concepts from this platform, do not entertain any form of distraction. And finally, if there be any part in this video you do not understand, when you watch it for the very first time, guys, you have the opportunity to replay the video over and over and over again until you understand it. Of course, you can understand it. And that's the reason why these lessons are coming in video format. And if at the end of watching the video over and over again, guys, you still have not cleared your doubts, don't hesitate. Just slide down to the comment section and document your questions. We will attend to your questions until you are satisfied. If this is taken, let's get to work. On the board, we are looking at integration of functions in calculus. Now we are in part B, integration of inverse polynomial functions. Now, in previous lesson, I mentioned that we have direct polynomials and we equally have inverse polynomial functions. I mentioned that you have direct polynomial function when you have a fraction in such a way that the function of s are at the numerator while the constants are at the denominator. But for inverse, the function of s is at the denominator while the constants occupy the numerator. So when we look at all the questions that we have here now, you will discover that the functions of x, they all occupy the denominator, while that of the constants, they occupy the numerator. So anytime your question is given in this pattern, understand that you are dealing with inverse polynomial functions. Now, I want to quickly explain the basic conditions to integrate inverse polynomial functions effectively. Listen carefully, because when you understand principles, you become a principal, and equally when you understand boundary conditions, you will not overstep your boundary. And for the fact that we are using shortcuts, you really need to open your mind to receive. So please avoid distraction. Now let me give you the secret. There are two basic secrets to solving problems on inverse polynomial functions effectively. One of the secrets is you must look out to see what you have as the power of x at the denominator. This is the first thing you do. You need to identify the power of x. Like in this question now, we have the power of x to be 1. Here we have 3, we have 2, we have variable powers. Now listen carefully. When the power of x at the denominator is 1, when the power of x at the denominator is 1, when you integrate the function, you have the numerator to the length of the denominator. I don't know if you understand this. Anytime the power of x at the denominator is 1 and you have a constant at the numerator, all you just need to do, pull down the numerator, then length of the denominator. It's as simple as this. Now, the same way if I have 3 over x now, this is the numerator, the length of the denominator. Has this answered your question? Yes. You don't need to kill yourself. That's why I mentioned earlier that you can see your question and get your answer without taking any step, without solving anything. Are you there? Now, if this is understood, so when you watch out for the power of x at the denominator and you find out that it is 1, all you just need to do, put down the numerator, then the length of the denominator. Now, what happens if the power at the denominator is greater than 1? This is the second secret. When the power at the denominator is greater than 1, you need to convert the fraction to what? A linear fraction. For instance, if I have 1 over x raised to the power of n, and n is greater than 2, or greater than or equal to 2, which means it's greater than 1, but the least is 2. So from 2 upwards, this is what my n is. All I need to do here is to convert this as what? N raised to the power of x raised to the power of what? Minus n, using the fourth law of indices. Then you can integrate. Increase the power by 1 plus 1, then all over n plus 1. This will become your answer. But I don't want us to go through this Israelite journey. I want to short it. And that's why we call it shortcut. There is a better way to have this done. Now listen carefully. To integrate a function of this type, when you have the power of x at the denominator equal to 2 or more, all you need to do first. Now this is the solution. Multiply the numerator by negative 1. So if I have this to be 1, for instance, minus 1 times 1 will give me 1. All over. Please pay attention to this. Stop it. First is to multiply the numerator by negative 1. Are you there? Next is to reduce the power of n by 1. So I have x is equal to n minus 1. Are you here? Then finally, use this value, this power here, as the coefficient of x. So I will just bring that this as if I am differentiating. This becomes n minus 1. This is what you have. And you will get to know, understand it very, very quickly. Now look at it. First is to multiply the numerator by negative 1. Then the value, if it was positive before, it will change to negative. And if it was negative before, it will change to positive. Then all over, reduce the given power by 1. Whatever you have as the new power, use it to multiply the function itself at the denominator. Let it become the coefficient of x at the denominator. If this is understood, without solving these questions for you, you can solve it. But let me solve it out so that you can get full understanding as to how to apply this model. Now let's get to it. All right, now we have solution. Number 1, y is equal to integral of 3 over x dx. So the first thing you do, identify the power of x. Of course, this is a fraction. There is no argument. This is numerator, denominator. Next, where is x at the denominator? Second, what is the power of x? The power of x is 1. So once the power of x is 1, pull down the denominator, take the mean of the denominator. So pull down the numerator, take the mean of the denominator, or plus c. Of course, you know that this can also be 3 log x base e plus c. Whichever one you use, they are all the same. Whether you make use of this or this, they are all the same. But you understand that this is subjective, so you must have had idea of what your options look like. When you have your questions, you have your options. So if your option is in terms of limit, then make use of limit. If your option is in terms of what? Log, then make use of that. It's as simple as that. Has this answered your question? I believe so. Now, this is the answer to this, one step at a time. Now, let's look at question number 2. Question number 2. We have y is equal to integral of 6 over x minus 2 over x all dx. Now, with what we have here now, we are integrating 6 over x with respect to x, and equally we are integrating minus 2 over x with respect to x. Now, we find that this is a fraction and this is another fraction. So we are subtracting one fraction from the other. Of course, I taught fraction in one of our lessons. So if you are not good with fraction, you can check our playlist and check a session where we deal with fraction. It will be of help to you. Now, at this point, all I need to do, having identified that this is a fraction, where is x? Is x at the numerator or at the denominator? At the denominator. I have passed that. Next, what is the power of x here? 1. And if the power of x at the denominator is 1, my answer becomes the numerator, lim of the denominator. Then minus, when I check the second fraction, the power of the numerator is a constant, the denominator is a function of x, inverse. Now, secondly, what is the power of x at the denominator? 1. And if the power of x at the denominator is 1, all I need to do is to put down the denominator, put down the numerator, then take the lim of the denominator plus c. This is the answer. Like I explained earlier, you can equally take this as log x base e. It's a matter of choice. As simple as that. Very simple. Principle makes you a principal. Now, let's look at question number 3. Question number 3. We have y is equal to 2 over x raised to the power 3 dx. Aha! Guys, first thing you do is to identify Whether you are dealing with fraction or not, of course, this is a fraction. Next, where is x? X is at the denominator, y the constant is at the numerator, inverse. The next thing I do is, what is the power of x at the denominator? Is greater than 1. And once it is greater than 1, you don't have a limit. So how do I treat this? Instead of converting this to linear, which would have given us 2x raised to the power of minus 3, then you now add 1 all over minus 3 plus 1. I'm going to teach you this shortcut. Of course, if you want to solve this in the conventional way, you will do it this way. Are you there? Anytime the power of x at the denominator is more than 1 from 2 and above, this is how you solve it. First of all, convert to linear. Then, when power at the denominator comes to the numerator, it becomes negative. That's exactly what we have here. Then increase the power by 1. Automatically, this would have given us 2 raised to power x raised to power minus 2 over negative 2. And this would have given us negative x raised to power minus 2. And we cannot leave our answer this way. This will give us negative 1 over x raised to power 2. This is the answer to this. You see, this is very lengthy. I want to teach you only one step to get this answer. Now, look at it. Y would have given us integral of now. The first thing you must do, having identified that the denominator has a power greater than 1, all you need to do is to multiply the numerator by negative 1. When I multiply 2 by minus 1, I have minus 2. Is this clear? Clear. Now, next thing I do is to reduce this power by 1. I will have x raised to the power of 2. Now, bring down this power to become the coefficient of the variable. And 2 goes into 2. This will have given us minus 1 over x raised to the power of 2. Does this agree to this? Guys, principles makes you principal. Don't memorize, just understand it. When you understand it, it's for life. So guys, what I'm trying to do in essence is that I want to help you meet up with time. And this is the reason why I take my time to teach you the secrets and the principles that works. There are principles that work. So what do you do? First is to identify the power of x at the denominator. If it's more than 1, multiply the numerator by negative 1. Then reduce the power by 1. Take the new power as the coefficient of the x. And that's all. If there is possibility of casting out, you do that and you have your answer. Is this wonderful? I think I deserve a hand of applause. Alright, now let's look at question number 4. Now guys, we are integrating this. And we find out that we have multiple fractions here. This is the first fraction, second fraction, third fraction. Now we are going to be integrating these fractions one after the other. Now, for the first fraction, the numerator is constant, the denominator is a polynomial function, and the power happens to be what? More than 1. If the power is more than 1, what do? I just have to multiply this numerator by negative 1. And when I multiply that by negative 1, I have negative 3 all over reduce 2 by 1. This will have given us raised to the power of 1. And we don't need to indicate that. If I remove 1 from 2, I have 1. This is x raised to the power of 1. So I prefer leaving it this way. Alright? Let's leave it this way. Then now bring down the 1 to multiply the what? The coefficients. And you understand that 1x raised to the power of 1 is the same thing as x. You ignore the power and equally ignore the coefficient. But you can choose to put it so that you have one more step. This is the new power. Then bring the power to become the coefficient. It's as simple as this. Then minus. I want to integrate 2 over s cubed with respect to x. Now the denominator is a polynomial function where the power is greater than 1. 3. What must I do? Now understand that this negative sign is connected to this. So I will have to multiply minus 2 by minus 1. That minus 1 is standard. So when I multiply this by minus 1, this will become plus 2 all over. Reduce this power by 1, which have given us x squared. Now bring down this new power to become the coefficient. So the power and the coefficient must be the same. Is that okay? The power and the coefficient of x must be equal and the same. Then for the last function, we are asked to integrate 5 over x. What happens here? The power of x at the denominator is 1. And when the power of x at the denominator is 1, guys, what do? You take the ln of the denominator. You see how principles work. If you don't know principles, you will always confused. Most of the time when we experience confusion or when we are stranded, is because we are short of principles. We are short-circuited. So when you understand principles, you will never be stranded. You can't be stagnated when you know principles. So all I need to do here, and I know that the power of x is 1. So I will put that in the numerator and take the lane of the denominator plus c. Then I can reduce this. I have y is equal to negative 3 over x. Plus 2 takes care of 2. I have 1 over x squared minus 5 ln x plus c. Arbitrary constant. This is the answer to this very question. It's as simple as this. Then finally, let's look at question number 5. Now we have question number 5. Y is equal to integral of 1 over 2x minus 4 over 3x cubed all dx. As simple as this. Now, these are all fractions. The first fraction I have 1 over 2x. Guys, do you agree with me that if I have 1 over 2x is the same thing as 1 over 2, 1 over x? Don't forget that this dot means multiplication in further mass. 1 multiplied by 1, 1, 2 multiplied by x, 2x. If this is agreed, then we can bring out the constant. So I want us to do a small mathematical logic here. Let's just extend this question a bit. But it's not compulsory. Alright, now, all I need to do, let's share the integral. This will have given us 1 over 2 integral of 1 over x dx for this first function minus, bring out the coefficient of this. This will have given us 4 over 3 integral of 1 over s cubed dx. Now, what you do here is when you integrate 1 over s, of course, we have this in our standard table. The power of s at the denominator is 1. So the numerator is 1. Ln of the denominator, which is the same thing as what? Ln x. Does that answer your question? So this will have given us y is equal to 1 over 2 ln of the denominator minus. Now listen carefully. Now listen carefully. What you do here, the power of this function that we are integrating is more than 1. And when the power is more than 1, you must multiply the numerator by minus 1. So when we multiply, don't forget that this 4 minus 4 is the numerator of this function. So when we multiply minus 4 by minus 1, we have a positive 4 over 3. Now, we will now reduce the power of this function by 1. Then we have this as 1 all over x raised to the power of 2. Now bring down the new power. As simple as this. Reduce the power by 1. We now have the power to be 2. Take the power as its coefficient as well. Then we can multiply all this, or this guy takes care of this. Then we have this finally as y is equal to 1 over 2 ln x plus 2 over 3x squared plus c plus c. This is the answer to this very question. Guys, this is very simple. I know you have learned a value from this lesson. Don't forget, the lesson that you should learn in this video or in this lesson is that 1, you watch out for the function that you are given. Whether you have variable at the numerator or at the denominator. If it is at the denominator, what is the power? When the power is 1, then the answer would have been what? The numerator ln of the denominator. Now, if the power is more than 1, then multiply the numerator, negative 1, then reduce the old power by 1. And whatever you have as your new power will now become the coefficient of x at the denominator. This is understood, guys. You have gotten value in this lesson. So, guys, if at this point you have not subscribed to this YouTube channel, please do consider subscribing to our channel and turn on the post notification bell so that you won't miss out when we release new content that will subscribe. Finally, don't forget to share this video, like this video, and make your necessary comment. Now, guys, you can quickly check the description below where you will find the link to the lessons. Love you guys. Thank you for watching. See you guys in